Okay, here we go. An electron passes between 2.5 centimeter long parallel plate electrodes that are 5 millimeters apart. 2 millitesla magnetic field perpendicular to the electric field between the plates. The electron passes through the electrodes without being deflected if the potential difference between the plates is 600 volts. Okay, so here I have my two plates, my electric field pointing from positive to negative. In order for the electron to pass through undeflected, my magnetic field must be pointing into the page. Here's my magnitude of my magnetic field, 2 millitesla. I'm able to find my electric field by taking delta V over the distance between the two plates, which is 600 volts over 0.005 meters, and I get 120,000 volts per meter as the magnitude for my electric field. So when this electron comes between the plates, since it's a negative charge, the electric force will be acting in an upwards direction. So therefore, my magnetic field must be directed into the page, which would give me a magnetic force in the downward direction, which will allow my electron to pass through undeflected because these two forces will cancel each other out. So for A, what is the electron's speed? Well, I can set my two forces equal to each other since it is passing through undeflected. So the electric force equals the magnetic force. So therefore I have QE equals QVB, and my velocity equals the electric field over the magnetic field, which is 120,000 volts per meter over 0.002 Tesla, which gives me 6 times 10 to the 7th meters per second for my velocity. Okay, so now for B, what if the potential difference between these plates is now 0? What is the electron's radius of curvature in the magnetic field? So now I have my magnetic force is still acting in the downward direction, so my electron will move in this fashion. So my magnetic force, so I need a relationship between my magnetic force and the radius. Well, my force is equal to QVB, which is equal to mass times acceleration. So here's my mass of my electron, and then for acceleration I can use centripetal acceleration, which is v squared over r. So I end up with this for r, which is the mass of the electron times its velocity over its charge and the magnetic field, which gives me 17 centimeters for the radius of curvature in the magnetic field for this electron.